We're going to look at dividing polynomials. So the first polynomial we're going to look at is we're going to look at dividing by a monomial. So what that means, dividing by a monomial, is we will have some polynomial in our numerator. That's upstairs. So for example, x to the fourth divided by 2x squared. So when I say dividing by a monomial, it means the denominator is a monomial. All right, so we've learned this when we have learned the rules of exponents. We can break this into a series of factors. We don't have to do these steps, but let's look at this to see what we get. Now, we can look at these first two factors. 8 divided by 2, that'll give us 4. When we look at these second factors, x to the fourth divided by x squared, well, a rule of exponents say that we will get x to the 4 minus 2, which is equal to 4x squared. So that's the basis of dividing by a monomial. So let's look at another example of a monomial divided by a monomial. And then we're going to make this a little more difficult to play with this idea, but we'll see a pattern emerge. So I can have 28 m to the fourth n cubed divided by 7 m to the third n cubed. So I still have a monomial in both the numerator and denominator. One term only upstairs and downstairs. So paint some sections here. We'll say, hey, let's look at this. 28 divided by 7. That's 4. Then we're going to look at m to the fourth divided by m cubed. Well, our exponent rules say that's m to the fourth minus 3, which equals m to the first. So we get m. And then lastly, we'll look over here at the end at n cubed over n cubed. Well, anything divided by itself is 1. And so our final answer, happily, is 4m. And that's how dividing monomials work out. We have done these. We have done these when we were doing order of operations, and we've done them when we were doing our exponent rules. What we want to look at now is what happens when I divide a polynomial by a monomial. So I have 8 x to the fourth plus 2x cubed. There's my polynomial. I'm going to divide it by a monomial. Now there are two techniques people tend to use to do this. One, I'm going to show you both techniques. One is you can think about how we get fractions with like terms. When we want to add or subtract fractions, we get them to have a common denominator. And then we put them together. What that does is that creates an addition and subtraction in the numerator. So this, going backwards from a common denominator, is equal to 8x to the fourth over 2x squared plus 2x cubed over 2x squared. Well, you just take a moment and convince yourself that what I have over here on the right-hand side, if I were to tell you to use a common denominator, you would get what was on the left-hand side. But we do this backwards now. Well, what's nice about this is I get two terms, an orange term and a blue term here, that are monomials divided by monomials, which we've already done. And that's one of the tricks in algebra that you'll keep hearing me say, is we take things that we don't know what to do with, and we make them look like things we can already do something with. So in this case, I've taken a binomial in the numerator and a monomial in the denominator and turned it into two terms, but with a monomial in the numerator and a monomial in the denominator, which we just did. And so this first term becomes 4. Oops, let me keep that in orange, the first term here. Sorry about that. Becomes 4x squared. And the second term becomes, we get 4x squared plus x. And so this is how we divide by a monomial. The other way people look at this is they kind of do the same process. I'll change color here. And I'm going to do a different one in a different way, which is 20y cubed plus, let me get my plus sign right here, plus 15y squared divided by 5y. What people will do is they'll divide each term by 5y. Well, that is saying the same thing as breaking it into two terms like I did earlier, but people will sometimes do that in one step. So there are one writing step, two mental steps. So they'll go, I'll divide this by 5y, which gives me 4y squared. Then they'll come over here and go, I'll divide this term by 5y, and that'll give me 3y. Both are mathematically doing the same thing. One writes it out so you can see each term and do the division individually. The other does it as a mental step. This will work for however many, for whatever degree your polynomial is up top, as long as you have a monomial downstairs. So let's show a more extreme example of this in orange. So 16x to the 4th y cubed minus, oops, minus sign went upstairs there a bit. There we go. Minus 12x cubed y squared plus, oops, where did my cursor go? There we go. 4x y. So I've got that all written down as my numerator. 16x to the 4th y cubed minus 12x cubed y squared plus 4xy divided by 4xy. So what I would do is I'd look at the top and go 1, 2, 3 terms. So I'm going to have 3 divisions. My first division, 16xy to the 4th y, 16x to the 4th y cubed divided by 4xy. So doing that division first, 16x to the 4th y cubed divided by 4xy. My second division is the second term. I'm going to keep the minus sign here. I get 12x cubed y squared divided by 4xy. Keep my plus sign, 4xy divided by 4xy. So the first division gives me 4x cubed y squared minus 3, keeping my exponent rules, x cubed minus x to the first, x squared. I should say x cubed or x3 minus 1 gives me x squared. Let me say that properly. And then y squared divided by y is y. And the last term's nice because anything divided by itself is y. And so we get 4x cubed y squared minus 3x squared y plus 1. And so this is dividing by a monomial, dividing polynomials by a monomial. Well, we can make this harder, and we will. We'll divide by polynomials. And we'll look specifically dividing by a binomial next.